So this is actually the third video that I have today. The previous one covered the previous two covered the class opener and practice problem and the previous questions on this homework. So right here we're going to start with number 4 on this video number 3. And if you understand this one right here, you should be able to do all of them. Okay. Now we need to remember our key concept. If you don't remember the key concept, it's y equals a. A is just a number. Sometimes it's just a negative sign, which means that a is -1. The b is the growth factor or decay factor, but right now it's just growth. The power of x minus h. H is your shift left and right, and guess what? We're not doing that in Algebra 1. It's only in Algebra 2, but it's there, so I'm leaving it there on our notes because it is there in Algebra 2. And the k is the shift either up or down, depending if it's positive or negative, the number that's being added at the very end. So does anybody know what the k shift of this equation is? What's the k shift? What's the k shift? -8. That's right. So the way to start graphing this problem, it would be to ignore h and k. And as you can see, there is no h value up here with the x on the exponent position, but there is a k. Just said that the k value is -8. So let's ignore h and k. I'm going to put a box, and you guys should practice putting a box around the function like that, ignoring h and k. And now from here, I'm going to use that parent graph function to make an xy table. And on this xy table, I'm going to use consecutive integer inputs. Now, what do I mean by that? I'm going to put a 0 in the middle. Then I'm going to put 1, 2, 3, like if I'm counting. And then backwards in the negative direction, -1, -2, -3. Now, of course, you're not going to need all these coordinates. And you could even have more coordinates if you wanted to. So let's start with the easiest input, 0, the easiest input. So again, I'm going to ignore, so let me put a box right here. I'm going to ignore that -8. I'm just going to focus in on this guy. So let's plug in the 0 right in there. Remember, inputs are the x values. 0 right there. What's 2 to the 0 power? 1, right? Anything to the 0 power is 1. And then 1 times 2. 2. So when I plug in 0 right there, I get an output of 2, and everybody should do that. Now, if I wanted to, I could plug in all of these inputs and do all of that math, right? I could plug in a -3 right there and say, oh, 2 to the -3, it's a negative exponent. I need to move it down. I end up with 2 over 2 to the 3rd. And that's 2 over 8, which reduces down to, it's pretty confusing, right? And it's a lot of math. The easier way is to understand that this is your growth factor. It's going to grow by this base value of 2. It's going to grow by 2, which means that this output to the next one is going to grow by 2, which means that this next one's what? 4. Growing by 2 is multiplying by 2. And then 4, it's going to grow by 2. What do I get? 8. Because it's growing by 2. You're multiplying by 2. And then the next one? 16. Now, if you don't believe me, check it out. Let's actually do the long way, the work. Let's take the 3, the input of 3, plug it in. What's 2 to the 3rd? 2 times 2 times 2? 8. And then what's 8 times 2? 16. So it's a lot faster to just come up with one easy output by plugging in 0, coming up with one easy output, and then using your growth factor to get to the next one. It grows by 2. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. So if it's growing by 2 this way, backwards it's what? It's dividing by 2, but let's use the word multiplication. Backwards is 16 times what? By 1/2. Perfect. And then 8 times half is 4. 4 times half is 2. 2 times half is? 2 times half? 1. 2 times half. What's half of 2? It's 1, right? Now, if you're thinking, why don't you just say divide by 2? I mean, you could. 1 divided by 2 is what? 1/2. But you see, I like using the word multiply because 16 times half is 8. 8 times half is 4. 4 times half is 2. 2 times half is 1. 1 times half is half. What's 1/2 times 1/2? 1/4. And those are our parent graph coordinates. This is the parent graph with the a value included. These are the coordinates of this red box. That is not our final graph. It is not. Because the final graph, we need to take into consideration that -8. the shift of 8 down. But right now it's covered up. Let me just graph what I have right here, and these are the parent graph coordinates. Let's start with 0, 2. If you have different colored pens, right now is the time to take them out and use them. 0, 2 is right here. 1, 4. 1, 4 is right here. 2, 8 is up here. And let's go in the negative direction. -1, +1. -1, +1 is right here. Right? If you're at the origin, you go -1, +1, it's right there. Let's go to the next one, -2, and then half. So if I go -2 on the x, -2 on the x, and then only halfway up, it would be right here, only halfway up. So let's all put a dot right there, halfway up on the -2 and then halfway up. And now if we go to the next one, -3 on the x and 1/4, that's half of the half, right? So if I go -3 and 1/4, that's not even halfway, it's only half of the half, which is even closer to the x-axis. And if I went to the next one, -4, it'd be 1/8, and then the next one, -5, would be 1/16. And we know that it gets closer and closer to 0. So -4, 1/8, 1/16, 1/32, 1/64, 1/128. At this point, all the dots look like they're just on the x-axis, even though we know that they're not on the x-axis, they're just infinitely approaching the y value of 0, but never actually touching. So this right here is it's the asymptote of our parent graph, but that's not our real graph. Okay, what do I still need to do to all these coordinates to get our real graph? I need to go -8 on all the coordinates. I need to shift it 8 units down. Okay, so when I take, how about this? Let's start with the asymptote. That's the easiest one. If it infinitely approaches y being 0, if I shift it 8 down, it's going to infinitely approach y being -8. Does that make sense? So I'm going to put my arrow right here because I know that that's my asymptote. It's going to infinitely approach y being -8, but never actually touch. It'll just infinitely approach it. I want to go to each one of these blue coordinates, and I want to go 8 units down. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to put a dot right there, but I'm going to use the red pen this time. And I want to take all these coordinates and move them 8 units down. 1, 2, 3, 4, 5, 6, 7, 8. And then I want to continue moving all the coordinates 8 units down. The other one right there, all of them 8 units down. This halfway point is going to go down halfway all the way here, or 8 units down to that other halfway point. And we know it gets smaller and smaller and smaller, and we already know it's infinitely approaching that asymptote, and the asymptote is y equals -8. So all we need to do now is connect the dots, put some arrows on each side of it, and we have our graph. Now let's answer a couple of things about this graph. So one thing to answer would be, what is the domain? So the domain are your x values, so you have to put x, and then you're going to put equals all real numbers. Because this red graph, it really does go to the left forever, and even though it grows exponentially, it continues to go this way to the right forever as well. That's why your x values are all real numbers. Or you could even think of it numerically with the XY table. You could plug in 0, you could plug in 1, 2, 3, 4, you could plug in 5, you could plug in 10, you could plug in 1,000, you could plug in -1,000,000 if you want, you could plug in whatever you want on the x's. That's why x is all real numbers. You could plug in any number you want. Now the y's, the range value are your y values. So let's put range, and we're going to be talking about the y values here. Now, the range is either above your asymptote or below your asymptote. Maybe we should define the asymptote first. What is the asymptote? What's the asymptote of this exponential growth function? Yeah, it's the k value of -8. So you're going to say the asymptote is y equals -8. Now what does that mean? That means that y equals -8, that's this horizontal line right here at -8. And we know that our red graph will infinitely approach it from right to left. It'll infinitely approach it, but it'll never actually touch it. It just infinitely approaches it. So the asymptote is y equals -8. Now our red graph is either above or below this asymptote value. So is our graph either above or below that asymptote? It's above. So how do I say that as an inequality? I say y is what? Greater than negative 8. It's not greater than or equal to because it never actually gets to negative 8. It just infinitely approaches negative 8, but it'll never actually get to it. And that's about all you could say about this question number 4. So you have to treat all of these or use this process on every single question, right? You always start by ignoring your h and k, just boxing in this, making an xy table for that. Use consecutive integer inputs. If you don't have your inputs nice in order, you're not going to be able to use the growth factor. Okay? So if you plug in 0, you get the output of 2, and then you could use the growth factor of 2 by making it grow by 2, by 2, by 2. Backwards would be dividing by 2, which is multiplying by half. Get your coordinates, shift them 8 units down, answer your questions, domain, range, asymptote. Oh yeah, we also have one more thing we could say about this. I forgot. The Y-intercept. The Y-intercept is the location of where your graph will cross the y-axis. So where does it cross? Here's the y-axis. Where does it cross? Negative 6. So we're going to say that the y-intercept is the coordinate 0, negative 6. It's a lot of different details about this one question, a lot of different answers from this one question, this one graph. So we answered the y-intercept visually. We saw the y-axis, and we saw that it didn't cross till down here at the coordinate 0, negative 6. But you don't have to do it visually. You could look at the whole thing, and remember, to find a y-intercept, you set x equal to 0 and solve. To find the x-intercept, you set y equal to 0 and solve. But right here, it's y-intercept, so if you want the y-intercept, you could set the x equal to 0 and solve for the whole thing if you wanted to find your coordinate for the y-intercept. So you could have said 0 is x, 2 to the 0 is 1, 2 times 1 is 2, and 2 minus 8 would give us the output of negative 6. Okay, so let's use those same exact steps to do number 5. So here we are on number 5, and again, I'm just going to ignore my k value for a little while, and you guys should all box this in, and let's make an xy table for that parent graph with the a value of negative half. Now, since the a value is negative, what could he tell me about this? Is it going to grow in a positive direction, or is it going to grow in a negative direction? Since the a value is negative, it's going to grow from left to right. It's going to grow in a negative direction. Okay? That's just something to know right there. The inputs are going to be consecutive integer inputs. So those are consecutive integer inputs. Now let's plug in the easiest number. What's the easiest number to plug in?
0.
Plug in 0 right here. What's 4 to the 0 power?
1.
And what is 1 times negative half?
Negative half.
Negative half. Anything times 1 is the same thing, right? Again, 4 to the 0 power, that's 1. 1 times negative half is negative half. So when I plug in 0, I get out a negative half. Now, ladies and gentlemen, I could continue to plug in 1 if I wanted to and to do the math. You know what? Maybe we should do that for fun this time. Let's plug in a 1 right there. What's 4 to the 1?
1. Oh, yeah.
Yeah. No, not 1. 4 to the 1 is what? 4. Now, what is 4 times negative half? That's negative 2. So the output is negative 2. Now, that was pretty easy, but there's an easier way of getting from this first output to the next output. And that would be using the growth factor. What's the growth factor? 4. So if I get the easy output negative half, how could I get to the next one? I need to multiply it by 4. It needs to grow by 4. So when I go negative half times 4, I get negative 2. And what's the next one going to be?
Negative 4. Negative 8.
Negative 8. And the next one?
Negative 16.
Really? What's the growth factor? Negative 32. So as you could see, it's growing by what?
4.
By 4. So backwards it'd be dividing by 4. Or better said, multiplying by 1/4. So what is negative half times 1/4? negative 1/8. And what's negative 1/8 times negative 1/4? Negative 1 over 32, which is really small. And what would the next one be? It's so small that it would be negative 1 over 32 times 4. Right? You're going to have to multiply this by 1/4 to get to the next one. But we already know it's getting incredibly close to what?
120.
To 0. Yeah. So I'm not even going to do that output. So let's graph what we have right here so far. 0, negative half is right here. Let's go to 1, negative 2. 1 on the x, negative 2 on the y, it's right there. Let's go to 2, negative 8. 2 on the x, negative 8 on the y, it's down here. And I'm not going to go to 3, negative 32 because that's way off the graph, right? If I go 3 and negative 32, I'm way off the graph. So I don't need that last coordinate. Let's go a little in the backwards direction. Let's go to the negatives. Negative 1 on the x, negative 1/8 on the y. So negative 1 on the x, negative 1/8, that's really small. So I need to put a dot really close to the x-axis itself. And we know that the next one, negative 2 and negative 1 over 32, that looks like it's touching the x-axis. It's so small. And we know going this way, it's just going to infinitely approach that 0 value. And normally I would just connect my dots and I'd say that's my asymptote right there and I'm done. However, this is not the final graph. We also have to deal with this shift of up 6. The k value is 6, which tells you need to shift it all up 6. So the asymptote that used to be approaching the y value of 0 is now going to approach what? The y value of 6. That's right. So let's go 1, 2, 3, 4, 5, 6 up here. It's going to approach the y value of 6. So I'm going to go to every single coordinate and move them 6 units up. So this guy, move it up 1, 2, 3, 4, 5, 6 right there. Put that dot there. You have to move every single one of them 6 units up. This one, 1, 2, 3, 4, 5, 6. And then even this one that was at the halfway point, 6 units up. 1 to the other halfway point, 2, 3, 4, 5, 6 to that halfway point. And we already know that it infinitely gets closer to the asymptote. So you could draw it like if it's actually on it. Connect your dots. Put an arrow on it. Your asymptote is this horizontal line. And let's answer some questions on this red graph. First of all, the blue one, it's not our real graph, so I recommend you putting 2 X's on it if you drew it, especially on a quiz or test. I need to know which one's your final graph. So I would put 2 X's because I know that this one's not my actual graph. It was my parent graph. This one, after the 6 unit up shift, after the K shift of 6 up, is the final graph. So let's answer some questions. How about the domain? What's the domain of this thing? Can't just say all real numbers. You have to say x equals all real numbers. Your inputs are all your real numbers. How about the range? Y is, it's either above or below your asymptote, and yeah, it's less than your asymptote value of 6. And remember, your asymptote, sorry about the horrible handwriting, but the asymptote is y equals k, and we know that k is 6, so your asymptote's y equals 6. That's that green line up here. So I've done 2 examples. I would like you to do the rest of these. Okay, so I did forget about the Y-intercept. Once again, sorry, Y-intercept. So where does it cross? It crosses at the coordinate 0, 5.5. So that would be your Y-intercept value, 0, 5, and 1/2.